morning, all of you. I am Dr. B. Satish Kumar, lecturer in chemistry, Government Degree College, Tekali. Today, I am going to explain NEET Chemistry 2023 question paper. Now, coming to the dehydrated under acidic conditions. So, morely dehydrating. Here, the two hydroxy groups is there. In this case, one hydroxy. Here also one hydroxy. Here also two hydroxy groups neighboring to each other. So, it's somewhat difficult. So, easy. We will form a conjugated diene product is there. It is a stable product. So more easily dehydration most readily possible in this case. So remaining all are wrong. So option 3 is the correct. Now coming to the peroxide disulfuric acid, sulfuric acid and pyrosulfuric acid, sulfurous acid. First of all, you know the structures of peroxide disulfuric acid. Peroxide disulfuric acid. The formula of this compound is H2S2O8, peroxide disulfuric acid, sulfuric acid H2SO4, pyrosulfuric acid H2S2O7, sulfurous acid H3, H2SO3, sulfurous acid, sulfuric idi, sulfurous. So the see this structure, peroxide disulfuric acid. So peroxide disulfuric acid, the formula of peroxide disulfuric acid like this. Peroxide disulfuric acid H2. So peroxy bonds is there. So here the option is, so one is 3 peroxide, 2 SOH bonds, 1 and 2, 4 SO bonds, 1, 1, 2, 3, 4, and 2, 1 SOS bond, SOO peroxy bonds is 1 is there. So 3. Sulfuric acid. The structure of sulfuric acid is H2. Sulfuric acid is this H2SO4. 2 SO bonds. So sulfuric acid is this 4 option. 2 SO bonds and 2 SO bonds. 2 SOH bonds, 2 SO bonds. Next pyrosulfuric acid and sulfurous acid. Sulfurous acid means H2SO3. So S double bond O, OH, OH, OH. So 3 H2 double bond H2SO3, H2SO3, S double bond O, OH, OH, H2SO3. The structure of H2SO3 this. So option is 2 SO bonds, 1 SO bond. So this is belongs to this. Finally, pyrosulfuric acid is this. So option 3 is the correct. Option 3 is the correct. Remaining all are wrong. Next bit is identify the major product obtained in the following reaction. So here the one keto group is there, one aldehyde group is there. Generally it is a Tollens reagent. Tollens reagent. In the presence of base condition, we will get only aldehydes positive test with this Tollens test or failing test to form, this is the product, salts of carboxylic acid, and also byproducts like this is also. So this is the major product. So see this structure where, so it is the fourth option is the right option. So keto group does not affected, this group is not affected, only aldehyde group is oxidized into carboxylic acid salts. So this is the form. So generally ammonium group is there. So this is the salt formation takes place. Next bit is identify the product. Acetaldehyde. Initially acetaldehyde, this is called acetaldehyde. Initially reduction with acetaldehyde. So acetaldehyde on reduction with LaH, lithium aluminum hydride, to form ethyl alcohol. This ethyl alcohol further H2SO4 heating. So dehydration reaction. So elimination reaction takes place to form H2O, H2O molecule, removing H2O molecule to form ethylene. This molecule reacts with HBr. So addition reaction takes place. So CH3, CH2, Br. This Br compound reacts with bromobenzene and sodium ether, it is a Wurtz-Fittig reaction. Wurtz-Fittig reaction. Wurtz-Fittig reaction to form ethyl benzene. To form ethyl benzene. So two NABRs. So it is a coupling reaction. So to form ethyl benzene. So ethyl benzene structure is this. So this is equivalent to C6H5, CH2, CH3. So right option is this. Next boss 95 question. The reaction at thus gives not takes place in blast furnace between 900 to 1500 kelvins. Temperature range during the extraction of iron is, so the remaining all are, so in this case Fe CO plus, this is the correct option, does not take place in the blast furnace. So this process is not easily takes place in the blast furniture. So all these are the possible. So this is not possible. So option 2 is the correct. Now coming to the pumice stone, it is a one type of colloid. It is a solid soul. It is a type of solid soul. It is a solid soul. So in this case, dispersion phase is gas. Dispersion medium is solid. So this is the solid soul. So solid soul is the correct. Next one is the complex compound is more stable. See this ligands based upon the EAN rule and remaining so many factors. See the ligands. Stability of ligands also, strong ligands generally, strong ligands forms stable complex, and chelating ligands also increases, stability also increases. See this case, amine, all are amine. See this case. So ethylene diamine. Ethylene diamine means it is CH2, NH2, CH2, NH2. This is called ethylene diamine. It is a bidentate ligand and also chelating ligand. So this this ligand, so chelating complex with central metal ion like cage-like structure or ring-like structures. These are the stable complexes. Stable complexes. So option A4 is the correct. Chelation increases, stability also increases. Now coming to the aromatics. So the different compounds. This is called naphthalene. So this is called cyclopentadienyl anion. This is called cyclobutene, cyclopropynyl anion. This is called cycloocta tetraene propynyl cation. This is called anthracene. See the pi electrons. Number of compound species which obeys Huckel rule. According to Huckel rule, molecule must containing 4n plus 2 pi electrons. That means n is equal to 0, we will get 2 pi electrons. N is equal to 1, we will get 6 pi electrons. 2 is equal to 10 pi electrons. N is equal to 3 is equal to 14 pi electrons. All these numbers are Huckel numbers. These compounds are highly stable. The compounds which follows Huckel rule shows aromatic nature, so shows higher stability. See this electrons. In this case, it is a 10 pi electrons. In this case, 2 to 4 to 6 pi electrons. It is 4 pi electrons. It is 2 plus 2, 4 pi electrons. In this case 2 pi electrons. It is 8 pi electrons. It is 10, 14, 6, 7 bonds is there. So 14 pi electrons. So obeys Huckel rule. It follows Huckel rule. It follows also Huckel rule 6 pi. It does not follow. It is all does not follow. It follows 2 pi. This does not follow. This follows. So 1, 2, 3, 4. Only 4 molecules follows Huckel rule. So option B is the correct. Now coming to the question. So the equilibrium concentration of species in the reaction A plus B gives rise to C plus D. The concentration given 2, 3, 10, 6 respectively 300 delta G relation. So already equilibrium constant, the formula of equilibrium constant is equal to concentration of C, concentration of D from equation, from concentration of A, concentration of B. So already given C and D. So the concentration of C is equal to 10, concentration of D is equal to 6 by 2 into 3. We will get 6. So 10. So 10 already the equilibrium constant is 10. So already formula is delta G is equal to minus RT log K. According to this, all these values we substitute here. So minus 2.303 RT log K. Here the substitute the values 3.32. Here the gas constant is 2. Or temperature is equal to 300 degrees centigrade at room temperature. That means to 300 kelvins and 300 into log 10 log 10 1 9. So this is called minus, calculate all these values 31.8 calories. So the delta G value is 13 minus 1381.8 or 80 calories. So option 4 is the correct. Now the balancing the reduction equation. This reduction, so it follows it. So we balance the equation, then we will get to the A value is equal to 1, 1, B value is equal to 3 and 8. So the balanced equation is Cr2O7 2 minus plus 3 into SO3 2 minus plus 8 plus gives rise to 2 Cr3 plus 3SO4 2 minus plus 4H2. So this is the balanced equation. So the coefficient is 1. Here the coefficient is 3. So 8. So option B is the correct.